Good morning one and all. Today we are going to learning about third unit. The unit name is creating an architecture 1. In previous sessions we are learn about designing the architecture, how to design the architecture, which styles we are using to design the architectures. Okay, na? After picking the particular styles, how to create an architecture. Here one means why specified one means here according to our syllabus, according to architecture point of view, we need to create the architectures 1 and also we need to create the architecture 2. Okay, now what 2, why 2 we will discuss later. In this class we are going to discuss about creating an architecture 1. Okay, that is important. So, we need to learn about basic points in this. So, we have to learn the things here, that is functionality and architecture. So, what is functionality? So, and architecture. Already we learned what is architecture and all. So, here we need to know deeply about functionality. Okay. So, functionality is the ability of the system to do the work for which it was intended. A task requires that may or may not the system's elements work in coordinated manner to complete the job. Just as farmers, electricians, plumbers, drywall hangers, painters and finish carpenters all come together to cooperatively build a house. So, that is functionality. What is the functionality? It is the ability of the system to do the work for which it was intended. Okay, na? So, functionality means it is the ability of the system. It says, it describes the ability of the system. So, what is the meaning of ability in general? We are having different types of system quality attributes generally. Those are availability, modifiability, performance, security, testability, usability. So, flexible. These are all the attributes, system attributes of a particular architecture. Okay, now these are the says the working of the ability of the system. So, those are all together is called functionality in general. So, that says the ability of the system, ability of a particular architecture. So, then creating the systems based on a particular architecture by using particular styles. Okay, now that is what functionality. Suppose we want to build a house, we want to build a particular building, whatever. We need some resources, some requirements. For example, place. So, how to design the particular place to construct a building, which type of designs we need to select. So, not only that, we need some infrastructure to construct a building. So, we have money, we have place, we have the designs of blueprints and also we have the material for that. According to that, we need to construct. Not only we are constructing the things for such a kind of things, but we required some people to construct it. Okay. So, like here we need framers, electricians, plumbers, drywall hangers, painters and finish carpenters all come together to cooperatively build a house. That is called functionality. So, therefore, if the elements have not been assigned the correct responsibilities or have not been empowered with the correct facilities for coordinating with the other elements. So here also we are coordinating these all functionalities together. Like this also we need to coordinating the other elements. Okay, na? So these are the, so that for instance they know when it is time or them to begin their portion of the task. So we are have the elements, we have the requirements, but it's not a main. Okay, now how we can arrange the elements, how we can perform the functionality, which one is the first and which one is the next, that is must and should. Okay, now so which functionality we have to do first and what next and what next. Okay, now that is the scenario we need to perform some particular thing successfully. Means arranging the elements together is not a thing, but arranging the elements in an order to for the excuse me, for providing good functionality. So that is functionality. So functionality may be achieved through the use of any number of possible structures. So for example, we want to construct a building, we need to see this is a single structure. Overall it considered as a single structure, but it's having the internally it's having possible number of internal structures. In fact, if functionality were the only requirement, the system could exist as a single monolithic model, as I said in my previous statement, with no internal structures at all. Instead, it is decomposed into modules to make it understandable and to support a variety of other purposes. In this way, functionality is largely independent of structures. Okay, now, so entirely it will be considered as a single structure. Overall, we can see there is no, we need to feel there is no internal structures, but when you are decomposed the particular entire the structure or a module, okay, now it is very easily understandable to the particular designers or architects or the users also. Okay, na? So otherwise it is difficult to understand the entire the structures. We need to divide the entire the structures into internal structures or internal modules, then only it will be easily understand to the each and everybody, okay, according to the stakeholder point of view. So that is the main intention or intended of a structure is nothing but a functionality. Okay, now we are dividing the, not only it says the ability of a system or working of a system, okay, now coordination manner of a system and arranging the task into a sequence order according to that task. Okay, now not only that, we can decompose the modules for the understanding while creating an architecture. These are all the things that is called functionality. Next, structure architecture, software architecture. Already we know what is software architecture, we learned so much, but here according to this point of view, software architecture constrains its allocation to the structures. Yes, allocation to the structures with other quality attributes are important. For example, systems are frequently divided to that several people can cooperatively build them. Okay, that is the main thing. So systems are frequently divided so that several people can cooperatively build them. So why they can divide it? They can cooperatively build the particular thing for easily understanding, for easy task and finishing the particular project within a period of time, which is among other things time to market issues through seldom stated this way. Okay, I mean when once the architecture is created, so okay, they need to deploy into the market. Okay, time to market. Okay, that is the main thing. Architecture and quality attributes. Achieving quality attributes must be considered as through design, implementation and deployment. Okay, now that is the architecture and quality attributes. The next concept, achieving quality attributes must be considered throughout design, implementation and deployment. Okay, now that is, these are the main things. we want to get the quality, we want to achieve the quality to the particular architecture. So these can be must be considered those design, implementation and deployment. Which design we are using, how to design it and how to implement it and how to deploy. Okay, when you are focusing majorly on these things, definitely we will get the ability of a particular system. No quality attribute is entirely depend on design. Okay, now why these three? When we are going to consider an architecture, design is not only a factor, we need to consider other things also. Nor it is entirely dependent on implementation or deployment. For example, okay, now Pavan, left ma, Pavan left, Pavan left. Okay, now that is the main thing. And usability involves both architectural and non-architectural aspects. Okay, now so whenever you following this usability, not only ability, it's mainly focusing on architectural and non-architectural aspects. So what are the architectural and non-architectural aspects? A non-architectural aspects includes making the user's interface clear and easy to use. Okay, now once the project is going to marketing, so they need to interface with that, communicate with this particular clients, users. Okay, now to easily we can advertise it. That is the non-architectural aspects first of all. That is why it is including making the user interface. Making the user interface means user relationship, user communication. So business is nothing but what? Buying and selling. Yes, ma. So once we create these architectures, must to be going to be buying and selling. So but it's how we can making an interface with this users. So that procedure is the non-architectural aspects mainly. So interface clearly and easy to use. Should to you provide a, for example, when architecture is going to use easily, so which type of buttons we need to use, which type of check boxes we need to use. So all these things we can be considered here. These are all the non-architectural aspects. So and also modifiability. The modifiability is determined by how functionality is divided. This is architectural, and why? By coding techniques within a module. These are the non-architectural. So modifiability is mainly focusing on it's defining the functionality. Is the architectural. That's how we can coding the particular modules. That is a non-architectural. Okay, thus a system modifiable if changes involves the fewest possible number of distinct elements. So once we want to modify the particular elements, any changes we want to make, so we need to careful about missing the content. Okay, na, don't want to miss the content. So actual it will be as it is, we need to keep same, but while the change modifying it, we don't missing the meaning of it. That is the main thing. Next, performance involves. So what performance involves? Both architectural and non-architectural dependencies. Okay, na? So what is the architectural means here? It depends partially on how much communication is necessary among components. So how much communication is necessary among the components? This is architectural. Okay, na? So when you are using these components or elements, they are interfacing together, they are communicating together, not directly, but how we learn already. Okay, now we are using pipes for interfacing. That is architectural. Partially on what functionality has been allocated to each component. That is architectural. That is also partially on how shared resources are allocated. This is also architectural. Partially on choice of algorithm to implement selected functionality. This is non-architectural. The performance is also, modifiability is also involved in involved in architectural and non-architectural, and also performance is also involved in architectural and non-architectural. Here our architectural in the performance is among communication among components, and how we can allocate each component together, and partially how share the resources are allocated to them. That is architectural. Non-architectural means choose the algorithms to implement the selected functionality, that is non-architectural, and partially on how these algorithms are coded. We need to selecting the algorithms and coding the algorithms. These are considered a non-architectural. Okay, na? So then the message of this session will be two folds. Okay, na? So architecture is critical to the realization of many qualities of interest in a system. Okay, na? And these qualities should be designed in and can be evaluated at the architectural level. And second one, architecture by itself is unable to achieve qualities. Okay, na? An architecture is not only get by itself the ability and qualities. Okay, na? By following these all, it will get these qualities and abilities. It provides the foundation for achieving quality, but this architecture is the foundation for achieving the quality. But this foundation will be to no avail if attention is not paid to the details. Okay, na? So when we are fail to get this good foundation for this particular architecture, definitely we will be failed. Okay, na? That is the main thing. So in the simple sentence, what we want to say, so okay, na? So when is the good architecture? We are having the good architecture, it performs the good functionality. When the architecture having the good functionality, it's have the ability of the system to do the work. Okay, that is main here we need to know. Next, and also let's begin our 4 quality attributes. Will be examine the following 3 classes. Okay, na? Those quality of the system, business qualities and qualities. Okay, na? So what is the quality of the system? So already I said, okay, na? When we say the quality, the system is quality, it's the ability. It is contains different types of system quality attributes. So as I said in the previous, here is the point, that is we will focus on ability, modifiability, performance, security, testability and usability. Okay, these are the 6 major software quality attributes. We are having these all qualities together, that is a good architecture. It's having the ability to do the good work. Okay, na? That's perform good functionality. So these are all we can learn in deep in later. Next, business qualities. Already I said what is business? Buying and selling. So means what? You make the interface between the users. The vendors make the interface between the users. Okay, na? That is the thing. Is mainly time to market. So we want to make good business. What is that main quality? Time to market. So the product will be released in time to market. So that is main important, that are affected by the architecture. These all things are affected by the architecture. Next, general qualities such as conceptual integrity, so and that are about the architecture itself, although they indirectly affect other qualities such as modifiability. So these are the things. Next, here we need to know another concept, system quality attributes. As I said, what are the system quality attributes? So system quality attributes have been of interest to the software community at least since the 1970s. There are a variety of published taxonomies and definitions, so, and many of them have their own research and particular communities. From an architect's perspective, there are 3 problems with the previous discussions of the system quality attributes. What are those? We have to see here. First one, the definitions provided for an attribute are not operational. So, whatever the definitions we need to take, those are not operational. So, it is meaningless to say that a system will be modifiable. Okay, na? So, according to that, not with only the definition we can't say that, okay, na, the system will be modifiable or not. Every system is modifiable. Yes, once we create the architecture, definitely we will update it. It can be modifiable with respect to one set of changes and not modifiable with respect to another. Okay, na? Once we want to change, we will change with some set of changes, but not only modifiable, others also. Okay, that is very difficult to the particular architects. The other attributes are similar. Next, a focus of discussion is often on which quality a particular aspect belongs to. That is also in a system failure, an aspect of ability, an aspect of security, or an aspect of usability. So, sometimes it will be failure, but on which based? On ability based, on security based, on usability based. Okay, now that is very difficult to say that. And also all these attributes communities should claim ownership of the system failures. Okay, now that is the major drawback. Next, each attribute community has developed its own vocabulary. Definitely they can develop their own vocabulary. The performance community has events arriving at the system. The security community has attacks arriving the system. The availability community has failures of a system. And the usability community has user input. All of these may actually refer to the same occurrences, but are described using different forms. So, that is the thing. So, when the architectures architect a particular architecture, they need to they are getting some problems, but they want to overcome those problems, they need to decompose the work. So, according to, for example, the security community mainly focusing on attacks. So, which type of attacks will comes, how to resolve them and all. Okay, na? The performance community is mainly focusing on events. So, how to perform the events, how to perform the arriving the things to the system. Okay, na? And also the availability community mainly focusing on failures. So, how the failures will be occurs, how to resolve them and all. And the usability community is mainly focusing on user inputs. So, they can be decomposed the task and they can be focusing on. Okay, na? Means the architects will take the help of some people. So, they can organize them according to this scenario. So, they will get the problems, but they need to resolve the problems meanwhile also. Next, quality attribute scenarios. So, in general, the quality attributes, we are having 6 types of, consists of 6 parts of quality attribute scenario. So, a quality attribute scenario is a quality attribute specific requirement. It is a specific requirement. It consists of 6 parts. So, what are those 6 parts? Source of stimulus, environment, artifact, response measure. Okay, na? So, we need to see what is source of stimulus. Here the source is either a user, either a client, either a developer. So, whatever it may be, okay, na, that is the source. Either it is a system also, okay, na, end user system. Okay, na, that is the source stimulus. What is the purpose of this source stimulus? This is some entity. Okay, na, what is the entity? Is a human, or is a computer system, or any other actor. Whatever the actor, that is an entity that generate the stimulus. Stimulus means is a requirement, is it some message, is it some acknowledgement. So, they can send something to that particular environment, means system. So, that is stimulus. Source of stimulus, sorry. Next, stimulus. What is stimulus? The stimulus is a condition that needs to be considered when it arrives at a system. So, once the acknowledgement or a request or a message from the particular entity, okay, it will consider the stimulus is considered as it is a particular arrival of a system. Next, environment. The stimulus occurs within a certain conditions. So, according to certain queries, according to certain conditions, it will be occurs. The system may be in an overload condition or may be running when the situations occurs or some other conditions may be true. So, this according to this environment, okay, the stimulus occurs when the stimulus is occur, when the queries occur to the particular environment within certain conditions, the system may be tell, okay, it is overloaded and it is busy or it is free, it means it is running or runnable. So, it can say the situation, okay, occurs or some other conditions may be true. Okay, next, artifact. Some artifact is stimulated. So, according to that the process is going on when the system is free. So, it is runnable, it will take the process and execute them. Okay, na? So, after that some artifact is stimulated. So, this may be the whole system or some piece of a system, but maybe it can be a process the entire the system or it may be piece of a system, that is artifact. Next, response. After processing is done, the process is done, okay, we will get some response. So, that is the response is the activity undertaken after the arrival of a stimulus. So, when the stimulus is occurred, then the activity is undertaken, that is response. Next, response means either positive response or negative response, whatever it may be, it will be the response. Okay, na? Response measure. So, when the response occurs, it should be measurable in some fashion so that the requirement can be tested. Here the requirement can be tested. So, these are the quality attribute scenarios. These are the this is main quality attribute specific requirement. It consists of 6 parts. What are those, ma? Source of stimulus, environment, artifact, response and response measure. Next, this is the simple context diagram for this particular quality attribute scenario. Okay, it shows the 6 parts. So, that is the source of stimulus. Who is the source of stimulus? Is an entity. So, what is the meaning of an entity? Is an actor, is a system, is another client, other user. So, then he sends some request, is some query. Okay, he is having something. Okay, na? So, that is send is some message, some query, some request, that is called stimulus. Where to send? Environment, that is a architecture, that is a system, whatever it may be, that is artifact. Okay, na? So, it can perform the particular system. It says the system is busy or it is runnable. Okay, it's any problem, it gives a acknowledgement. Okay, na? Then it can process the entire system or some part of the system, that is artifact. Then we can get the response, either it is a positive response or negative response. Then we can measure resource measures. We can have the resource measure according to time to time. Here they can mention the 1, 2, 3. What is this? This is a time manner. Okay, it can execute the first acknowledgement, then it can give the response. This is the arrow says so taken the processing it and gives to the particular person. Okay, na? That is the main thing. Okay, na? Acknowledgement and the request and response. Okay, na? Okay, meanwhile we are it takes some time is mentioned it. Okay, na? So, that is a percentage response measure, that is the percentage of it. Okay, na? These are the 6 types of parts we are having in a particular quality attribute scenario. Next, here next concept, quality attribute scenarios in practice. Okay, na? So, 6 types of quality attributes we learn. So, we can see them one by one. The first one, availability scenario. So, what is availability scenario? So, availability means what? Availability is considered with a system failure and it is associated consequence failures are usably a result of a system. Errors that are derived from faults in the system. It is typically defined as, so how alpha is equal to mean time to failure by mean time to failure plus mean time to repair. So, like this. Next, here also we are having 6 types of 6 parts in this also, that is the source of stimulus, stimulus and other also. Okay, na? So, this is a architecture for this particular one. So, here is also a source of stimulus. Okay, na? We differentiate between internal and external indicators of this. Okay, na? We can explain this concept in the next class. Okay, na? In this concept we can learn about the functionalities and architecture and what are the quality, system quality attributes and business quality attributes and qualities we can learn here. So, what are the architectural and non-architectural aspects, and also what are the problems occur in general to the particular architect. These are the things we learn in this session. Okay. Thank you one and all.